Nice. Hey, Brian. So we're back again for another Wi-Fi podcast. Had an electrician in there today putting a generator plug in case we get on the storm, but the power's back up, so we can do it.
Wait, was your power off?
You know, it was. He didn't actually even have to shut it off, so I didn't lose power at all. But maybe the next hurricane I will, and I'm ready to go. So, all right. So first, I wanted to talk about Wi-Fi 6E. So, I was doing a little digging, and it looks like there's finally some consumer routers that support Wi-Fi 6E, and Linksys has one, and I think maybe Asus has one, and I'm seeing some testing, and these guys are getting some pretty good throughput numbers, like 2,000 megabits per second. So. So finally, when we have our business class Wi-Fi 6E access points, they're definitely going to be using that 2.5 gig port. Did you see the roadmap at all? Like that, they're going to have 2.5 gig.
Oh yeah,
100%, right?
So definitely be able to take advantage of it.
Yeah, and it looks like there's a pretty good supply of like Intel. Wi-Fi 6E cards for laptops now too, the AX210. So those are out. Now we just need some more business class Wi-Fi 6E APs to come out that we can test.
Yeah, we have there's somebody at our office that bought one.
Yeah.
And installed it into their laptop and tested it, and the Wi-Fi speeds were crazy.
Yeah. I've seen these early testers, and yeah, so finally, we're gonna have these, multi-gigabit speeds that were promised, right? That we haven't really seen with Wi-Fi 6, although it's a great improvement over AC Wave 2. But so Wi-Fi 6E looks like it's gonna be no joke. We just need to get it in the smartphones and in the enterprise or business class access points, so that we can take advantage of it. We don't mess around with that consumer stuff at all. So.
But did you probably did not see it in the new iPhone then? That's coming, right?
I didn't see the spec sheet. The event's in like a few days, so we'll see if it has it or not. I don't know. I haven't heard any rumors that it will, but it could.
I think it's too early for.
Yeah, Apple waits. Apple waits. Like we said last time, I think the Android phones will probably adopt it right away. And then Apple will wait and see what happens, right? So make sure the market's adopting it, or the chipset's available, or what have you. But anyway, so some of the uses for Wi-Fi 6E, I was kind of looking to see where you'd want to use it. So places like hospitals where you want like a dedicated mission critical Wi-Fi network separate from everything else, right? So that's going to be pretty awesome. You have 6 gigahertz to use just for like certain mission critical functions of your business, right? If you want to, that's like one way to do it.
For Wi-Fi 6E?
Yeah, for 6E. So let's say you're on the trading floor, you're in a hospital, you have like these devices that have to stay connected on Wi-Fi. You can move them to a whole new frequency range, not contend with anything else out there.
Yeah, for like the early adoption though.
Yeah, but right, it'll be early adoption, but there may be some applications out there that they actually need this really bad. Like they need to get rid of all interference, go to this new band. You know what I'm saying? That's one thing we never thought about, really.
Well, the thing I think about is like you're going to have this early adoption, and then you're going to have all these consumer products come out.
Yeah.
That will operate on that. So
right.
In the same situation that you were with 2.4 and 5 gigahertz, right? Mm-hmm. Or what do you think?
Well, it'll fill up quickly, but I think there's a lot more spectrum available. So we're gonna have a lot more channels. I think it's gonna be a whole new thing. It's gonna be greenfield out there for a while. And if you have a mission critical application, definitely should look at 6E. That's where you're gonna want to go.
Yeah, yeah. If you ever look at, I don't know if you have the actual chart that shows you 2.4,
Yeah.
5,
Oh
and
yeah, it's
6.
huge. The
It's amazing how large 6 gigahertz is compared
right.
to the 2.4 and 5.
Yeah. I don't have it.
So
I don't have
now
it.
a majority of our products are operating on 5 gigahertz, so meaning like our phones or laptops and things like that. So
Right.
we thought that that was like pretty good, right? So we're running out. We've already ran out of space on the 5 gigahertz, but 6 gigahertz is so large. I'm looking at a chart right now that we
Yeah.
have on the website. It's larger than 2.4 and 5 together. So
Yeah. Yeah. So
that,
there's huge number of a huge amount of new spectrum there, and let's say you're on the stock trading floor. You could just outfit all the laptops with Wi-Fi 6E card. Now they're available. You could snap them in there, put in Wi-Fi 6E access points, and you'll have your high speed network going, right? Um, so that's one thing. Now, there's going to be a lot more capacity too. So anything like engineering, um, video streaming, things like that, where not just basic video streaming like we're doing. Like I'm talking like hundreds of streams. Like if you're doing some sort of like rebroadcasting or something. And engineering, we're sending around giant plans, things like that. The added capacity is really gonna make a huge difference.
yeah. Oh yeah. I mean, just looking at 6 gigahertz. So talking about 5 gigahertz really quick. So
Yeah.
you know, that's where everybody's going. That's where everybody is right now. 5 gigahertz. It used to be 2.4. 2.4 got too crowded, so they jumped to 5 gigahertz. 5 gigahertz gives you more, more speed, less distance, but more speed. Just a point of reference. So we have two. We can create two 160 megahertz channels,
Mm-hmm.
and that's going to give you the max speed.
Right.
Right now, a majority of people are probably on 40 megahertz. If you're at home, you're probably using 80 megahertz. That's how you get your maximum speed. In a business application, you're probably not going to use 160, 80. You're probably using 40 or even 20 in some cases.
Yeah.
So 6 gigahertz will give you 760 megahertz channels.
Yeah.
So in 14 80 megahertz channels and 29 40 megahertz channels.
Yeah.
So I mean, it gives you a lot more room to, like you're saying, to expand and for speed. Yeah, so it's pretty incredible.
Yeah. So, but again, like you mentioned, the distance on 6E is probably going to be smaller. So, smaller than 5.8, right? So, maybe not by much, because there's always like efficiencies in the new chipsets and everything. But we're expecting it to be a little bit smaller, at least. Maybe it's like same room type technology, but when you absolutely need high data rates, sending around big files or streaming, low latency, and mission critical applications, then 6E looks like it's gonna be the way to go. So I'm hoping to get our hands on some products soon that we can test and sell. But yeah, it looks from what we're seeing out there, the consumer stuff is working pretty well.
Yeah, we definitely have plans for 6E. So, and it most likely it will be a tri-band.
Yeah.
24, 5, and 6.
Yep.
So that will be rolled out. But we'll supply more information as that comes down the pipeline.
Cool. Yeah. So I mean it's pretty exciting. We'll see where that goes, but I think it's going to be adopted pretty fast. All right. So you wanted to talk about something else, like SSIDs, like how to troubleshoot your SSIDs if you're having a problem.
Yeah. So you run into particular issues, and this is a practice that we do a lot of the time. So there's two situations that come in regards to troubleshooting. One, it's a new network, it's set up, and there's problems.
Yeah.
Or there's an existing there's an existing network, and then they start having problems, right? So this is true for both those cases. So we have customers that come in and say, okay, I have client devices that are having problems with X. Maybe it's a gaming device, maybe it's a particular client. And one of the troubleshooting steps, which I would recommend for anybody to do, is that you have devices connecting to the broadcast name or the SSID, right? So we can have up to 8 SSIDs, and each of those SSIDs can be programmed in different ways with different types of authentication types, different types of protocols can be enabled, and so on. So what we do as a best practice, if you ever run into a problem or a situation where you have a client device connecting to an access point, this is true for any vendor's access point. Ours, whoever, it doesn't matter. So if you ever have a client or a number of clients that can't connect, or they're experiencing some really slow or weird behavior, and you've checked all the physical connections and things like that, and it comes down to the SSID or the radio configurations, but more specifically the SSID, what you want to do is you want to create a new SSID, a test SSID that is really a basic SSID. It's just a broadcast name, and it's broadcasting on maybe on 2.4 and 5 gigahertz, and you might even say just put it on 2.4 or even just put it on 5 gigahertz.
Yeah.
But it depends on devices and what you're trying to test. So typically we create a test SSID on 2.4 and 5 gigahertz and leave it open, no security whatsoever. As you're testing, you can do it 2 ways. You can have your SSID that you created with all your features on there, or you could have a really like a dumbed down version of an SSID with nothing on there, vanilla kind of SSID. So you can do it both ways. So you can either start adding features or start taking features away and continuously test. So what we typically do is, if there's an SSID, we'll start to add these features that they currently had on their SSID, and we'll test each step of the way. So, for example, if a client's having connectivity issues and you're using WPA3, we'll leave it open, let them connect. If they can connect, no problem. Then we'll add in WPA3. We'll apply changes. We'll actually reboot the AP every step of the way, just to make sure that you have a fresh kind of start with the AP and the configurations on the actual AP. And as you go, you can enable like 11R, which is one of the protocols for roaming, 11W. You can then start to add in like dynamic VLAN pooling, or like a particular VLAN, enable like what we call as application analysis, or you can add in like band steering. So you can start to add these features as you move, rebooting every time, every step of the way. And what you're doing is you're testing, okay, where does the issue lie? And so you can identify like the particular problem.
Yeah. So they're experiencing a problem, and instead of like setting it up the same way every time, beating your head up against the wall because it's not working, start out real basic, no encryption. Because even I've seen a lot of times people will have the wrong password, in the laptop for a certain SSID, wrong password, wrong algorithm, maybe WPA2 and they have it set to WPA3 only or something like that. It could be locked in the laptop, and until they forget that network, it's not going to work, right? So starting out with no encryption makes sense there. And that's just, and then adding the encryptions is the most basic. If that doesn't work, they're definitely have the password mismatched on their computer or device.
Yeah, that's why we have we have ran into devices or client devices that can't use WPA3 yet.
Oh yeah.
So they're a little more, they're legacy devices. So you have to go back to WPA2 PSK, for example, and use that until like that person updates their device, or IT updates that device. So, and then you uncover these particular issues with these different clients as you kind of strip away the SSID and start adding these features on as you test.
Yeah. So did you use this for, you said like gaming consoles or something were having issues?
Yeah, it was on a larger network. And their network's a little more advanced, so they have a lot of different authentication types within their SSID. So it's right now, we're stripping away like all these advanced features and then adding them back in. And if the test is successful, we leave it on and we go to the next thing and add that on, and then test it again. If that feature also works, then we add on the next feature, and so on until you find a point of failure. Then if you run into a feature and say, okay, we've added this 5th feature, for example, and there's failure, it's not working, Then you strip everything away and you only apply that one feature, and then you test it with just that
Oh,
one feature.
gotcha. Okay, yeah,
You
that's
know,
smart.
there's a problem with this. Is it a bug issue? Is it a client device issue? What is the issue basically?
Yeah, and then let's say you had some legacy 11B devices or something that weren't working or couldn't authenticate with WPA3. You could set up a separate SSID for them, right? And
Those devices, and you run into that in like enterprise networks or large networks, and you have IoT devices.
yeah,
You put them all on one SSID, for example.
even like printers, things like that. They're all 11G mostly, right? Or 11N maybe. Some of them.
Yeah.
So yeah, it's a good idea to set up that second separate SSID. Not try to run everything over one size fits all, because you're gonna have to compromise on your security probably for your majority of your devices, right? Just to support a few.
Exactly.
It's
Yeah.
one of the cases you'd want to have another SSID. You want to have as few SSIDs as possible, but it's better to have separate out your Internet of Things, printers, things like that, low speed devices onto one SSID maybe.
Yeah. But you brought up a good point in regards on the laptop side. If you're testing a particular, like a laptop or a device, you always want to forget the network and then rejoin the network.
Yeah.
That is definitely key, because we actually go through that process a lot.
Yeah. Yep. Definitely forget it on the phone, on the computer, because it's remembering that SSID the last time you connected it worked. If you made any changes to the SSID, or it could even be on another site, that with a whole different configuration, it's not going to work. It's not going to connect, because it could be WPA2 that you connected on last time, right?
Right.
And now maybe you change it to WPA3, or this new network has WPA3 only enabled, right? So yeah, definitely if you can't connect with one device, forget the network, and also upgrade your drivers too.
Yeah, that's a big one.
100%, because we've seen that a lot too, where if one device doesn't connect but the others do, then it's most likely that device. So update the drivers. And I think we said this before. Go in on Windows, go into Device Manager, and delete the wireless adapter, and just refresh Device Manager. It'll discover it again, reinstall it with all fresh settings. Because if you tweaked any of the settings in there, then that could cause it to not connect also. So delete that adapter, let it re-find it, and then it's basically freshly installed with the most chance of it working.
Yeah.
So, all right, Brian. So anything else you want to talk about this week?
No, I think that covers pretty much everything.
That's good for this week. All right. Well, remember to like and subscribe. We still have lots of switches. If anybody needs them, let us know. I know that it's hard to find switches out there. People have been calling like mad, but we have pretty good inventory. So if you need any PoE switches, let us know.
Or non-PoE switches.
Or non-PoE. We have non-PoE too, but we don't like to sell those as much. But all right.